Alright, so here is a couple parts from Home Depot that we're going to put together for our first hybrid rocket engine. I'm going to go over them one by one and tell you what they are. There's only one part here that's really custom made, and I'll show you what that is and how we did it in a moment. Alright, so the main thrust chamber of the engine is this. It is a steel pipe nipple from Home Depot. What we're going to do is we take these reducing fixture fittings we also got from Home Depot, and we screw them on here and here. Now, the next part is, for a hybrid engine to work, you need an oxidizer and you need a fuel. We're going with one of the most basic oxidizer-fuel combinations in hybrid engine history, which is wax, paraffin, and oxygen. So usually they use nitrous for nitrous oxide. We're going to use oxygen because you can't get nitrous oxide at Home Depot, but you can get oxygen. To interface this, we had to actually buy a torch kit because there's a special thread on the oxygen bottle. So to interface an oxygen bottle with the engine, we had to get a torch kit and do some surgery on it to make a fixture for it. Here, that fixture attaches to this piece here. Which now gives us an oxygen flow that we can interface with this thing here, with one of our reducing fittings. But we're not going to directly do that. We have a measure of control in this ball valve. So actually we have two valves on here. We have the valve that is actually integral to the coupler to the oxygen tank, and then we also have the ball valve to actually trigger the engine when we want to, so we can pre-pressurize this part of the line. The reason why we did this is because we wanted to include an oxygen chamber, so we could pressurize an oxygen chamber and then disconnect the oxygen bottle. We could do that. That's a safety feature we might take advantage of when we actually do the test. Now, the only part that's a little bit different here is the nozzle. The nozzle is made out of copper fittings from Home Depot, but I did some machining on them. I inserted an aluminum insert. Aluminum insert converges by 45 degrees, or actually 90 degrees, because it's a 45 degree half angle, which is a little bit steep, and it's held in by these screws. Now I'm going to show you what real manufacturing is like. I'm missing one of the 6. I'm not actually missing a fitting there, but that's a tap. I broke one of the 440 taps when I was doing it, and removing a tap that is that small is very, very, very difficult. You might as well dynamite the piece. But I figured that a tap would be as effective as a screw, so I just cut it off and, ground it down, and there you go. We're going to melt down our Gulf wax, which you do not need a permit to own, and we're going to put a mandrel in here that's going to be called a port, and we're going to cast the Gulf wax into there. We might use a shorter length of pipe in the actual test, but we have this longer piece of pipe just for demonstration purposes. The Gulf wax will be the actual fuel. The oxidizer will flow into there. We'll ignite with steel wool and an electric battery. We're going to take the steel wool and we're going to put it in the front end of the chamber where it's heavily oxidized, and then trigger a 9-volt current through it, which will cause combustion or some kind of heat reaction, which will then ignite the entire propellant. And hopefully we'll have a rocket engine out of about 80 bucks in parts from Home Depot, which is way more than I wanted to spend. But I was hoping for total cost of Home Depot $140 because I had to get the stupid torch. But let's assume you have a way to get an oxidizer in there that's not so stupid, and you can do it cheaper.